In this lecture, we will discuss the product and sum rule. The product rule and the sum rule of probability are two basic probability rules that play most important roles in many fields of applications. Example, quantitative genetic analysis. Product rule. This mainly applies to determine the joint probability of two or more independent events. Independent events means that the occurrence of one event does not affect the occurrence of the other event. For example, on tossing a coin, the probability that the second outcome will be a head will not depend upon the first event. Next, sum rule. It is mainly applied to determine the total probability of two or more mutually exclusive events. Mutually exclusive events means that the events cannot occur at the same time. For example, when considering the events day and night, both events will not occur at the same time. Now let's look into detail the product rule. If A and B are two independent events, the probability of both A and B occurring is the product of the individual probabilities of A and B. That is, P of A and B is equal to P of A into P of B. In case of multiple independent events, that is up to A1 many events, A1, A2 up to AN, the product rule can be expanded like this, P of A1 into P of A2 into P of A3 into up to P of AN. Now let's discuss an example to understand this concept. A randomly selected couple has two children of different ages. What is the probability that the first child is a boy and the second is a girl? Giving birth to a boy and a girl are equally likely events. So, therefore, they have the same probability. Therefore, the probability that the child is a boy is equal to the probability that the child is a girl. Since there are two outcomes, therefore the probability is 1 by 2. That is equal chance. That is the gender of each child is independent of the other. Both are independent events. Therefore, we can apply the product rule. Therefore, the probability that the first child is a boy and the second child is a girl is equal to probability that the child is a boy into probability that the child is a girl. Which is equal to 1 by 2 into 1 by 2, and that's equal to 1 by 4. That is the joint probability. Next is a sum rule. If A and B are two mutually exclusive events, the probability of either A or B occurring is the sum of the individual probabilities of A and B. That means the probability of either the event A or B occurring is equal to the sum of the individual probabilities. That is P of A or B is equal to P of A plus P of B. And in case of multiple mutually exclusive events, that's up to events ranging from A1, A2 up to AN, the sum rule can be expanded like this, P of A1 plus P of A2 plus P of A3 up to P of AN. Now let's look in an example. In a country X, 47% of the population has blood type A and 20% has blood type B. What is the proportion of the population that has either blood type A or blood type B? each person can have only one blood type. Having a blood type A and blood type B are mutually exclusive events. Therefore, let's apply the sum rule. Therefore, P of blood type A or blood type B is equal to probability of having blood type A plus probability of having blood type B. And is given in the question that P of probability of A having blood type A, probability of having blood type A is 4% and that of blood type B is 20%. There's a 4% plus 20% and which is equal to 67%. So if we have to choose the rule like this, if both the events are independent events, then we have to choose the product rule to find the joint probability. And if both of the events are mutually exclusive events, then we have to apply the sum rule to find the total probability. Thank you.